Today I'm going to do number 27 in chapter 4 of our textbook. So we've got these two blocks on a ramp at an angle of theta. First block is of mass m, second block is of mass 2m, and they're connected by cords. They want us to find the magnitude of the tension T1 in the upper cord and the magnitude of the tension T2 in the lower cord in terms of m and theta. That means that I shouldn't have anything except for m and theta in my answer. Okay, so we've got two objects, which means we're going to need two free body diagrams, both of which are on a slant. So I'm going to do M1 down here. Okay, they're on a slant, so forgive me if it doesn't look so good, because it doesn't, usually I just tip my whole head and like tip everything to the right, but it won't let me do that with this software, so that's the best I can do here. The forces on M1 are gonna be, let's see, we've always got gravity. Okay, in this case it's going to be mass times gravity, which is m times g. Okay, and we've got the normal force, and we've got, let's see, tension number 1 is going to be pulling it kind of up the way here, and then the second rope is pulling it down, so that's going to be T2. So we've got four forces here, and let's just go ahead and call let's call up the ramp negative and down the ramp positive. There we go. Okay, the other object, okay, it's going to be 2m, and it's also on the same slant. Oh, that was really bad. Okay. Oop, come on. Having trouble, sorry. Wow, well, it's really sloppy, I apologize. Okay, and we have, make these thicker, there we go. We have gravity. This one is mass times gravity. The mass is 2m, so it's going to be 2mg. We have the normal force. Okay, it's a different normal force, so I'm going to put 2 here. And then up the ramp I've got T2, same T2 as the last diagram, and that's it. Okay, last thing I need to show where on these diagrams the angle is, and if the angle that the ramp makes with the horizontal is theta, then theta is going to be the angle that gravity makes with the y-axis. And over here, right here. Okay, so next up is Newton's second law. Let's do Newton's second law for this one first. Okay, just because I got more room. So F net in the y direction is going to be 0, and all it would tell me is the normal force. They don't care what the normal force is, so I'm going to skip all that, and all we care about is the x direction. So F net in the x direction is m a. Okay, F net, well, the only thing pulling down the slope in the positive direction is the part of gravity that is in the x direction. So this bit. That is going to be 2mg sine theta. We did that in class. So 2mg sine theta minus up the slope is T2. Okay, that equals m times, well, if this is all being held by ropes, it's not going anywhere. So the total acceleration is going to be 0. So what I have is 2mg sine theta equals, or minus T2 equals 0. Okay. I'm going to solve this for t2, just add t2 to both sides, and what I get is 2mg sine theta equals t2. Okay, that's supposed to be an m. Well, that's actually the answer to B. However, I do only want this in terms of m and theta. Well, here's theta and here's m. Probably should put that g, multiply it out with the 9.8. Most physics problems, they let you leave the g as a g. So I'm going to take both answers. I'll either take 2mg sine theta, or if you want to, it would be 2 times 9.8 m sine theta, which would be 19.6 m sine theta for t2. Okay, so I'm taking either this answer or this answer. They're both fine with me. Okay, let's see, just draw a line here. Now we're going to do this diagram. Kind of out of room on this side, so I'm going to do that over here. Same thing, F net, the extraction, is mass times acceleration in the x direction. Okay, so F net in the x direction, we've got T2 pulling down the slope. We've got the x component of gravity pulling down the slope, sorry, that was also too long, but it's going to be mg sine theta. Only mg this time instead of 2mg because the mass is only m, not 2m. Okay, then up the slope I've got t1, and that all equals mass times acceleration, again, is 0 because it's going to stay at rest. Okay, this time I want to solve for t1, so I'm going to go ahead and just add t1 to both sides. So what I get is t2 plus mg sine theta equals t1. Then for t2, I'm going to put in the value for t2 that I found before. So t2 was 2 mg sine theta. I still have this plus mg sine theta equals t1. So what I have is 3 mg sine theta. So t1 you can either write as 3 mg sine theta, that's acceptable, or you can put in 9.8 for g, in which case you get 3 times 9.8 mg sine theta, or m sine theta, sorry. Okay, which is, you know what, I'm almost out of room, we'll go this way. That is 29.4 m sine theta. Okay, that's T1. There we go. Okay, and that's all they wanted, so we are done.